Hi everybody, this is just an overview of forces. So when you have forces acting on an object, Newton's laws applies. So if all the forces are balanced, then the object will either be stationary, or if it's moving, it'll move at constant speed in a straight line. Remember the straight line, okay? Because the moment you change direction, then you need an unbalanced force. And when all the forces are balanced, we say the object is in linear equilibrium. So it's possible to have two or multiple forces that are balanced. So when you have two forces, they can be up or down, left, right, inwards, outwards, whatever. But the sizes are the same, and they are balanced when they are the same size but opposite direction. So you need one pointing one way, the other one pointing the other way. It's also possible to have more than two forces that are balanced. So here's an example of three forces that are balanced. It's like having three teams in a tug of war. They can be held stationary or moving at constant speed. So how do you know they are balanced? If you add them vectorially, that means if you add them head to tail. So this blue represents that. And that's your red and that's the orange. They form a closed triangle. Just remember, they're all head to tail, so there's no resultant and there's no gap. Okay, if they did not form a closed triangle, then it would mean they're not balanced. Now, just looking at force components. So here's an example of a box that's on a slope. And the forces acting on the box are your reaction force, which is at right angles to the surface, and gravity force, which is mg, which is vertically down. Now, if you resolve the gravity force into two components, one of the components is along the slope, and this component of gravity is responsible for bringing the box down the slope. The other component is actually pushing the box into the slope, but if the box is not sinking, then this other component, these two lines are parallel, should be equal and opposite the reaction force. Okay, and the component of gravity, so this is your angle, which is the same as here, is your mg sine theta, because that's opposite, and this is your mg. Okay, then let's look at force and acceleration. So when forces are not balanced and you have an unbalanced force, you have what's called a resultant force. And this resultant force causes acceleration, and the direction of acceleration is the same as the direction of the unbalanced force. How do you know something is accelerating? A few things can happen. It can start moving, it can stop moving, can change the speed, or it could change direction. Okay, and what we need to remember is that the direction of acceleration is the same as that of the unbalanced force. Now in level 2, just be careful when you have questions with force and acceleration. Remember to use the component of the force in the direction of motion. So I've got an example on the next page. So here you're pulling a box with a rope, and the box is moving horizontally, but this rope, that's a tension force in the rope, is 25 newtons, and let's say that's 30 degrees, and I put in friction as well. Okay, acts opposite to motion. So what we need to do is, not all of the 25 newtons is used to pull the box forwards, because the box is moving horizontally. So it's only the horizontal component of that 25 newtons, which you get by 25 cos 30, which is 21.7 newtons, is used to move the box forward. Now, however, there's friction that opposes motion. So your unbalanced force, or your resultant force, you've got to subtract the two, and you get 16.7 newtons to the right. Okay, include direction. And if you have to calculate acceleration, you use F equals ma, and I've just made the box 3 kilos, so you divide one by the other and you get your value for acceleration. The next part of forces has to do with torque, which is the turning effect of a force. And this measuring, so this torque is either clockwise or anti-clockwise. So this torque over here, if there's something here and you're pulling it down, torque is always circular, okay, whereas force is linear. Okay, so torque is F times D or F times R, which is the size of the force times the distance from the pivot. This dot is the pivot. Now, conditions for equilibrium is there are two conditions. Translational forces are balanced. That means the sum of the downward force equals sum of the upward force. So this symbol here, sigma, means sum or total. And then your torques are balanced. That means your total clockwise torque equals the sum of anti-clockwise torques. I've just written it symbolically. The two possible questions on torque, two types rather, one of them is with a single pivot. Pivot can be anywhere along the object, and if it is balanced, then the torque, so this one is your anti-clockwise torque equals clockwise torque. The force is acting in this particular case would be that M, and then that M, and then if that is your pivot, then you got your support force, but you could also have gravity acting down this way. Okay, but let's say this is, so this mass times that equals that mass times that, just to balance that, okay, and including the mass of the thing as well. But if they say this doesn't have any mass, then you don't need to do that. Okay. And then for your equation, when you write, remember to include the g, but then you can cancel that off, so you don't have to, so your numbers are a little more friendly. The value for g is 9.8, okay, because m times g is your gravity force. Your type 2 questions are when you have two supports, and often you are asked to draw all the forces acting. So if you've got supports, wherever you have a support, the force is always upwards, okay, because it's supporting it. And then remember, whatever the object is, its mass or gravity force acts through its center. If you have something, I just put a cat over there, so that's your weight force or gravity force of the cat. Okay, and then you can use in order to solve this, if you've got, let's say, pivot 1 and pivot 2, you choose one of them, support 1 and support 2, you choose one of them as the pivot, and then you take all distances from the pivot, okay, and you work out, so this is your clockwise torque, these two, the cat and that will be equal to the sum of your anti-clockwise torque. So that's your distance times the force plus that distance times the force should be equal to this whole distance times that force. And then you can find the value of Fs2 because that's your unknown. And once you find that, in order to find this, you just use the total force downwards equals total force upwards to find that unknown. Okay, and then often don't forget to include the mass of the bench, which acts through the center in this one too. Okay, this one I assume this doesn't have any mass, so that's why I didn't include it. But if it has mass, remember to include that. And then the last part of forces is to do with circular motion. Now you've got circular motion at constant speed in level 2. It is accelerated motion even though it's going at constant speed, simply because its direction is changing. And if something is accelerating, there has to be an unbalanced force, and this acts in the same direction as your acceleration. Now what I've drawn here, the black arrows, is the tangential velocity. So the direction in which something is moving when it's going in a circle is always a tangent to the circle is that point. And your centripetal force, which points towards the center, acts at 90 degrees. So it doesn't have any component in the direction of motion. But what it does is not to increase the speed, but to change its direction. So that's what the centripetal force does. And so whenever you have an unbalanced force, you got acceleration. Now, acceleration for circular motion, because it's going in a circle, is given by v squared over r, where v is the speed with which something is moving around a circle and r is the radius. So how do you get the centripetal force, which is your unbalanced force? It's ma. So you got the m times v squared over r. If you don't know the value for v squared, but you know the radius and the time something takes to go around a circle once, that's a period, then you can use v, which is the distance, is 2 pi r over t to get v, and then you can find one of these. Okay, so